Bismillah, Assalamualaikum warahmatullahi wabarakatuh. So this is the second part of the comments and feedback on to the students video presentation submission for MECH 2118 Automotive Engineering Lab 1. So hopefully by now you have watched the first video about the first experiment. This is to continue off for the second experiment. You have submitted two videos. I have watched one video per group, and this will be the second video for each group, inshallah. Hopefully this will be less in terms of length compared to the first one, for 9 groups. So I didn't anticipate it to be that long, but evidently it becomes long when you have 9 groups that I have to go through and watch, and for each one I have to give some comments. Right, so first we will see, just to refresh into the instruction. So this is from iTalim. Submission deadline, you have submitted on deadline, alhamdulillah. And then because this comment is given so that you can prepare for the 28th December group experiment report, right? So for the presentation, so just to go reiterate, you can, if, because this will be just to reiterate the same thing as the previous video in terms of the instruction, you can straight away jump to whatever timeline that you want, or timestamp according to what you need to view in this video, right? So again, the objective is to discuss the achievement of the objective of the experiment from analysis of data obtained from internet search, right? So from the internet search data, from the data obtained from internet search, then you have to do some analysis and how far you can achieve the objective. Second, to present the analysis that the group have managed to do. So this is a presentation, and obtain the feedback. So this is the feedback conversation here, right? So again, the flow that is expected, because it is specifically mentioned, reiterate the objective of the experiment, number one, and why certain procedure is needed. So I do not expect you to outline the whole procedure, just why certain main part of the procedure is needed in order to achieve the objective, right? That's number one. And then number two, briefly cite the sources found and used for the analysis. And number three, what is the outcome of the analysis and how it leads towards the conclusion, meaning the connection is what is I'm looking for, not meaning I do not need the final conclusion if it's not yet available, but how it leads is what I'm looking for. So the format is 4 minutes maximum that is specified. So that's why one of the element that I see or take note of is how long the video submitted. No need to verbally introduce the team member, just display the important information for 5 seconds. So which experiment, group number, and group member name and matrix, right? That's it. So let's go to the submission. So we first go to group number 1. So it is Google form here. So this is group number 1. Alright, so it's 2 minutes and 40, so it's within. So this is group number 1. Okay, so group information is already given there. Alright, so let's listen to the presentation.
Bismillahirrahmanirrahim. Assalamualaikum warahmatullahi wabarakatuh. We from Automotive Engineering Lab, Section 1, Group 1. Our group members are Muhammad Rahimi, Muhammad Aizat, Hardino Hakim, and Amir.
Assalamualaikum warahmatullahi wabarakatuh. Today I want to present about Jominy End Quench Test. First we'll look at the objective. There are 3 objectives. First, to analyze the hardness and toughness of the materials using Jominy quenching rate test. Second, to know how heat treatment works. And the last one, to understand the effect to the material from heat treatment.
Okay, so in terms of the objective, several things here, because Jominy test is quite how to say, because we know already how it is designed and to study what elements, right? So I will touch on this at the end of the video if you are not clear yet, for any group watching, or in particular this group number 1, just because in terms of this, if you because when you say to analyze the hardness and toughness of material, no, we because toughness is not part of the test, right? Unless you do, the Chappie test on the Jominy specimen, which you don't. So this is meaning in term of the, you state the objective, but it's wrong objective, number one, because we do not have toughness there, unless I'm not sure what is in your procedure, but because you say toughness here, so I note that. And then to know how heat treatment works. Okay, because if that is the objective, the final conclusion must be, okay, this is the conclusion on this, right? This is how, but it is not to know how, okay, to understand the effect of material. Okay, okay, to be blunt, none of this objective is accurate enough to describe what is the reason we do Jominy test. I'll do some example of how to search about this at the end of the video. Please look at the very end, inshallah. Hopefully I remember to put it there.
Why the certain procedures need to achieve objective? First is hardness. Hardness is indicative of tensile strength value. Second, Jominy. A test has been created to see how well a metal hardness increase when quenched. Next, quench and cooling rate. Cooling rate varies between different steel. And then hardenability, the ease of metalsite formation or the necessary cooling rate, as it's easier to cool slowly. And the last one is the result, to plot hardness against quench and distantio hardenability curve for the sample.
Okay, several things here that is like, okay, hardness is indicative of tensile strength value. Is it? How is hardness related to tensile strength? Okay, so think about that, because I don't even know what that means, and what that is that statement really correct? And then Jominy test has been created to see how a metal hardness increase when quenched. No, not really, because to see how hardness increase when you quench, you don't need Jominy test. You just use the small metal, etc. You quench and then you can see hardness increase, right? It doesn't need Jominy. Jominy have a specific purpose. Look at the end of the video. Quench and cooling rate varies. Okay, so I'm not sure how this statement explain why any procedure. Quench and cooling rate varies between different steels. So are you actually measure for different steel what is the quenching rate? Really? Hardenability. Okay, this is a keyword that is related to Jominy test, hardenability. But please understand what it means, because I didn't explain this at any of the previous video. When I explain about, maybe it's my fault, when I explain about Jominy test, I just use layman word just to explain what you can see when you do this thing in the lab. I didn't explain what is the theory. So many students just take what I said and do not refer to the theory and just speculate, and everything goes, I do not know where it goes, right? So please just Google what it means and how this test actually provide information to understand hardenability. And then result plotting hardness against quenched and distance show hardenability curve. Okay. Okay, so I think you find something that is getting close to the actual explanation, but from what you write here as a whole, it doesn't make sense. try to explain this to any of your friends. Ask them whether they understand it. If they don't, it means that something is wrong, because if the explanation is clear, anyone can understand it.
For the outcome, in the review, the Jominy test shows how different metals behave when quenched and their ability to increase hardness. So in the experiment, we can use up to two, which is alloy steel and carbon steel. We can see that the hardness of the alloy steel is higher than the carbon steel. And why is
Okay, so okay, now I get some of the idea, because you find a study that actually use different material. Because in our lab we do not have a different material, we just have one material, right? So yeah, meaning from that perspective, there's a reason why they use two different material, right? But there's two. If that is the case, you have to differentiate the two objective. One, what is the trend? One is the two line for the two material. You have to be able to describe how it relates and why this procedure is used to get what, right? And so far, okay, did you cite the source? No, right? Okay, no, so that will harm you unless you put it at the end, maybe. But in terms of the flow, analysis done. Did you have analysis done? What is the analysis? Because
in
you
the
just
review,
say,
the Jominy test shows how different metals behave when quenched and their ability to increase hardness. So in the experiment, we can use up to two, which is alloy steel and carbon steel. We can see that the hardness of the alloy steel is higher than the carbon steel. And why?
okay, so you have to specify what are you trying to analyze, because when you just say, okay, this higher than this, but even without heat treatment, uh, alloy steel may already have higher hardness than carbon steel, right? So meaning, if that is the case, if before you do any process, even quenching, if you put the value alloy steel and carbon steel, if it's like that, and then after it's still like that, so what do you want to conclude? Meaning, there's some analysis that you can try to based on this plot, you can already analyze certain things. But I think because when you lack, you don't have any objective that is clear, then of course the analysis is nowhere to be found, because you don't even know what to analyze, right? So I'm trying to find where I can give mark. So this is making me, it's very hard to give mark when I don't, when the element requested is not there. Okay,
The
let
alloy
us
steel
see.
is higher than the carbon steel. And why is this happening? Because in our conclusion, the Jominy End Quench Test is the standard method for measuring the hardenability of steels. This describes the ability of the steel to be hardened in depth by quenching. The hardenability depends on the alloy composition of the steel and can also be affected by prior processing, such as the temperature. That's all for us. Thank you.
I use two reference, which is PH by James and
Such
I use
the temperature.
Okay, the source is given at the end. At the end, so I'll give something there, even though it's not, in according to the, because there's a reason why I put in the sequence like that. Anyway, now when you do conclusion, right, it has to be based on, conclusion cannot be something that you Google, because this is what I want to show, because evidently you find what is the purpose of Jominy test and what is hardenability. This should be at the beginning, and then, meaning that you do experiment and then you conclude based on the data. That I think maybe many students think that conclusion is for concluding remarks, right? They give certain speech about something. In lab, it's not like that. When you do get the data, you analyze and you conclude based on that analysis. How is Jominy End Quench Test is a standard method is the conclusion? How? Right? It doesn't make sense. You talk about this graph and then okay, based on that the conclusion is the Jominy End Test is a standard method. What? Right? It doesn't make sense. The vulnerability depend on the alloy composition. If that is actually a conclusion from a certain process that you do, there must be certain discussion about alloy composition. But there's no discussion about alloy composition in your discussion, right? So how can you suddenly conclude, oh, it is depending on alloy composition? It doesn't make sense. So what I'm trying to push here is that to train you to have something that makes sense. Bottom line, right? When the whole report doesn't make sense, the mark will make sense in relation to that, but it will be bad. But hopefully you significantly improve in your report, right? Otherwise, the whole mark will be so bad, because hopefully the report will have more marks from the presentation, and inshallah it will be, because the presentation it have a smaller scale. But if you continue like this, the mark will be severely terrible. For the presentation, unfortunately it is, but you still have opportunity to redemption for the redemption in the report. Please do take the opportunity to improve, inshallah. All right, so that is group number 1. So basically, to recap, the objective, totally you have to relook at that, why the procedure is needed. Some element, especially at the end there, it's nearly going towards the right direction. Please rethink based on this conclusion. Just rethink why we do that. Okay. Measuring hardenability. What is hardenability? Because we want to test that. That's why we do this in this way. That kind of things. In terms of why the procedure. Analysis. Do some analysis, please. Okay. If anything is not clear, the Google Classroom is there for any question. I already give the platform to ask, so that's why the mark will assume that you have all the opportunity to clarify on everything. So if you do not take the opportunity and the result is unfortunately terrible, do not be surprised if the mark is terrible as well. Okay, so going to the group number 2. So this is for group number 2. Let us see. So it is an YouTube link. Let us see. So it's 3 minutes 30. All right. Group number, etc. Okay. Okay, you specify 3 objectives. Interesting. Okay, first you say distinguish, because I'm showing my way of evaluating, so that you know what you should think about when you do the report. Because when you say something is the objective, I will seek for the analysis to justify this object, to achieve this objective, and the conclusion with respect to this objective. If it's not matched, unfortunately the whole thing crumble. So you want to distinguish between hardness versus hardenability. That's interesting, because it's 2 different things. But you say the objective is to distinguish what method you choose, etc. Because that basically is just literature search, right? And then you say to understand concept of mass effect. So I'm interested to see what you conclude about that. To perform as a method to indicate. What do you mean by that? Indicate huntability. Indicate to as a method to indicate huntability. Okay, to perform something is normally not an objective of lab. It's a way, it's a procedure, it's a method. The outcome is the objective, right? So so because it can be okay to distinguish, to understand, it can be an objective, but it's not an objective of a lab. It's objective of a reading assignment maybe. Okay, so the objective is stated, even though my comment is there. The why the certain procedure is needed is not mentioned, is it? And then you cite the source. Of course, the source is the same as the group one. I guess maybe many of the group will find the same source. That's not weird. And then this is the analysis, I guess. Wait, what is the cooling rate? How do you okay, on the bottom is the, because you didn't explain, right, what you understand from here. So you have the distance, so obviously on the left is the where the quenching happens, and then the distance further, and then is it, yeah, that's something. And then you have the hardness, so at the quench end is highest, and then it goes down, the hardness goes down, and the different curve is different grade of steel, I think, right? That 4340 4140, is it? Because the title is hardenability curve for different grade of steel, so I assume that different curve is different grade of steel. So when you say when the test continue with increasing distance and decreasing number of cooling rate, what do you mean by that? When the test continued with increasing distance, so do you, I'm trying to understand what you write. When the test continued with the increasing distance, because it is not, what do you mean by test? What test are you talking about? Okay, so okay, because the missing part here, you have nothing in terms of to highlight why certain things is done in the procedure. For example, you say we will test this and this and this different alloy and steel, and why we use different, because we want to see how the curve differ, for example, right? Then it makes sense when you do analysis that, so I can capture, okay, then. But now it's suddenly being introduced without any introduction in the procedure on why, because I have to decipher myself what this means, what is this, this is different material, etc., right? Okay. Okay, that's quite good because yeah, if I think if anyone try to find the explanation behind Jominy test and what is the analysis going on, you can find all of this, but you have to make it connected, right? Because those theory is as if like it is a standalone without the previous. Meaning, how does it explain what is observed previously, right? So you have to improve that part, I guess. mm, yep. For the outcome, the higher hardenability, the deeper. hmm? Okay, so for the conclusion, one is because you said in the objective to distinguish hardness and hardenability. mm, and then to understand the what is this concept of mass effect or something, and then third, so do look back at your objective, because the objective is the one that tallies directly to the conclusion, right? When you say the objective is to achieve this or to test this or to see what happened with this, the conclusion say it happened like this, meaning it directly address the objective. um but there's some of the statement here in the conclusion as well. Please take a look whether it is correctly worded or something. For example, the when you conclude for the outcome, the higher the hardenability, the deeper the formation of martensite from its surface. So what the statement can be true, but what does it mean and how does it relate to your analysis, right? Meaning that which one of your specimen is the higher hardenability, and how do you conclude from whatever you see that the higher the hardenability, then the deeper the formation of martensite, meaning how do you illustrate that deeper, meaning yeah, that kind of thing. Because if it can be correlated, at least it illustrate that you understand how this conclusion comes about, right? Otherwise it seems like you find it somewhere. All right, so that's group number 2. Okay, hopefully for okay, this is group number 3. So we have Jominy here. Okay, for the time everyone achieve for this test less than 4. All right.
Assalamualaikum warahmatullahi wabarakatuh. For
Waalaikumsalam.
Jominy End Quench Test, we have two objectives. First one is to analyze the effect of the different quenching or cooling rate on the hardness, and the second is to determine which cooling rate is the best in terms of hardness.
Okay, I guess this is how I worded it, or meaning when I explain what you can physically see in the test setup and how to understand why a certain thing I'm what you can appreciate. Maybe the way I worded it, make the student misunderstand to understand it is exactly in this way, because when we say if we want to test purely what happened at the different cooling rate, you just put one at the ambient, one under cool water. That's already differentiate the cooling rate, right? But for Jominy, when you link with hardenability, it's not just that. It's not just that. It is because when it's a bulk of material, when you quench, you put in water, every surface is cool, but it have some thickness or whatever. So if this is bigger, meaning towards the inside, it have different curve of temperature drop, right? And how will it be? That's basically related to hardenability. So the the design of the Jominy, the quenching process, why is it like that, is why it's not everything deep in water, is just to illustrate that, right? Because only the surface get quenched, but inside It's not directly, right? It's cooling down as a result like that. So yeah, so in terms of the objective, you have to look at the end of the video when I'll show certain things that you can directly search online in terms of understanding Jominy test and hardenability. Like, just look at the end of the video, just to reevaluate on the objective. Okay. Because when you say to determine which cooling rate is the best, how? Meaning which cooling rate? Meaning, okay, I'll write it down. To determine which cooling rate is the best, right? So if you word it like this, I do want to find in the conclusion which cooling rate, meaning your conclusion is this cooling rate is the best in terms of hardness, this cooling rate is worse in the meaning I will look for that. So I took down the objective, and we'll look into the analysis how do you find which is the cooling rate best cooling rate, and what is your conclusion. If that is not missing, then something wrong with the objective.
So there is some important procedure that we need to do in order to achieve our objective. So to determine which quenching rate is better, we need to test our specimen on the Rockwell hardness device at a different distance to obtain the value of hardness for the specimen after we're done with the quenching. So after we obtain all the value, we need to table all of the data, and then we need to plot a hardenability graph of Rockwell hardness versus distance from quenching end. So from this data, from this graph, we can observe clearly how is the pattern and which rate of quenching have a highest hardness.
Okay, so Alhamdulillah. I guess the way you describe it here, because you are affected by the way I described it earlier, right? In the video earlier. The way, because we want to see, but when we say we want to, when you phrase it as you want to determine which quenching rate is better, what do you mean by that? Because we do not know the quenching rate, right? So you it's yeah, because if you want to determine which quenching rate is better, you have to know what is the quenching rate, but you don't know, right?
Quenching have a highest hardness. For the part of data, we successfully collected a total 5 data from different sources, neglected the same data that the group members collected, and all of the data actually have almost similar in the result of the experiments.
Among all of the sources that we have searched for this experiment, we choose this graph as the reference. The data of the experiment is collected from various sources. One table of cooling rates associated with distance is shown. We can see that the increasing of distance from the end of the specimen will make the cooling rate slower. One of the graph, which is the hardness versus distance from quenched end for Jominy End Quench Test, also shown. We can see that the highest hardness, which is from 50 to 60 unit, occur when we quench the water at the end of the specimen. At this point, we can say that the cooling rate is the fastest, which is 170 degrees Celsius per second. And the distance of 1 inches, the hardness is around 30 to 40 units. And at the distance of 2 inches, the hardness is just under 30 units. Both of the distance have the cooling rates of 5.6 and 2 degrees Celsius per second respectively. From this data, we can see that the hardness will decrease with the increasing number of the distance from quenched end.
Okay. I'm not sure whether you intend for the listener to understand what's going on here, right? Because is it related to this graph before? And why is it like, okay, where is it? Where is it? It's shown just a slip, some second, and then you just say something, and without, because the explanation is best when you have diagram. When you just put writing like that, so all those words should be explained by showing this, right? And then highlighting what, where are you talking about. So otherwise how can I follow, right? So, and then okay, you inches, okay, that is the distance, the inches is the distance, I believe. That is Fahrenheit or Celsius per second, is it? Is that measured, or is that, do you know where that number come from, the 170? Is it measured with a tool or from a slope or what? Right, so without that, cooling rate associated with distance. Yeah, because I'm not sure whether this is a calculated data or something, right? You, because there's something missing in the story, but you just use it because it is not, because in Germany it is not an input, right? It's not something that you design. Okay, at this distance, the cooling rate is to be this one. That's a, how to say, that's a byproduct of cooling at only the end, and then what happened consequently, right? But anyway, a decent attempt, even though let's see the conclusion. Oh.
The increasing number of the distance from quenched end. From this experiment, we can conclude that the difference of quenching rate will give us different effects on specimen's mechanical properties, which is the hardness. This is proven by the various pattern of the graph that we obtain. We also
This proven by various pattern. You never show, but suddenly you make a conclusion.
can conclude that the fast cooling rate is the best in terms of hardness.
Okay, if you want to conclude like that, it doesn't need a Jominy test. You just do like the first one, right? You just put in water, leave it ambient air. That should already can lead to a conclusion in this consideration about cooling rate, right? Because on air it will cool slowly. When you put in water, it's cool dramatically fast. So how should I mark this? Because at least you are being consistent with the objective, even though it doesn't require Jominy test to achieve this. But for report, you have to go, you know, we'll discuss a bit at the end of this video. Just go there about the purpose of Jominy test and about hardenability. It should relate back to that. Alright, so oh well, so I'll try to give as fairly as possible. Alright, so let's go to group number 4 here. So let's see.
Assalamualaikum warahmatullahi wabarakatuh. We are from group 4 who want to present the second experiment, which is the Jominy End Quench Test.
Assalamualaikum. The objective of this Jominy test is first we want to study the effect of different cooling rate on these specimens. Second, we want to determine the hardness of different point intervals in a different metal specimens. And third, we want to be familiarized with Rockwell hardness testing machine.
Okay, I guess the number one, you are, you just try to take what I just specify what happened, or rough idea about, what we want to see in the previous video. But I think just you have to review the objective based on the actual purpose of Jominy test and related to hardenability. Just take a look at the very end of the video. We'll discuss something is related to that. To determine the hardness of different point in interval, that's not really an objective. That's a procedure actually. What you do, you do that to achieve something. So that something is the objective, right? Why you do that? Why you find hardness at different point? And to familiarize, of course, that is objective of going into the lab for students. But in terms of the objective, the test itself is not just to familiarize with certain method, right? It's actually to get something. So we are talking about that kind of objective, right? So mm, uh,
For the methodology part, to answer our main objective, which is to study the effect of different cooling rate on a specimen, we must use a Jominy test setup tank. So basically, we must put a cylinder-shaped specimen in the oven and take out from it immediately. Then we quickly put the specimens into the Jominy setup tank and direct the water flow to the bottom end of the specimen. Using pencil, we mark the positions of various points and take the hardness value using Rockwell hardness testing machine. This step is important as mentioned in the objective that we want to determine the hardness value on different point interval.
Next is result analysis.
okay, so several things. One is when you have the diagram of there, right? The diagram of the Jominy, the quenching setup, the quenching, I don't know, the tank setup, right? That's the purpose of that. So that is the important thing. Why is it designed like that? Because I think you try to provide a reason why the procedure is in a certain way to relate to the objective, but it is because the objective itself is not really the full purpose of Jominy, so you just focus on that. So yeah, but what I'm mentioned about this one, because you mentioned here about the flow or the bottom of the sample, but the diagram is before, so it doesn't help, right? So when you are highlighting something, the diagram should be there together with the highlight. Anyway,
On this
Graph, it shows the alloy steel has the highest hardenability. This indicated that multi-site formation is greater than the plain carbon steel. High volume fraction of multi-site developed when high hardness and lower hardness indicates strong formation to benite, ferrite, pearlite microstructure. Next, this is the different result analysis where we get from the other source. This graph shows some different steel where 4340 steel, 3140 steel and 1040 steel, where 4340 steel is an alloy steel, 3140 steel has low alloy steel, and 1040 steel is a plain carbon steel. As shown, 4340 steel has high hardenability, maintaining a higher hardness even an inch away from the quench. Multi-site formation is prevalent and will happen even at slow cooling rates, while 1040 steel requires a quick quench for multi-site formation. This is the last result analysis where we can get from the other source. In this graph, we can see at identical quench rate, the hardness of each alloy is different. The farther distant from quench, the lower value of hardness. So, the different alloys will give the different hardenability.
Alright, so to conclude,
Okay, so you have to really decide what is the conclusion, what is the input, what is the, what is being observed, and what is the known input. If the hardenability is the one that we want to conclude, or is the observation, the input is something else, right? Meaning that different alloy with a different, I do not know, something. So because throughout the analysis, I'm not sure whether which is which, because when suddenly you say different hardenability produce different things that you observe, meaning that the hardenability of the material is already known, meaning that this have better hardenability than this one. So when we test, it gives this and it gives this. But on another page, you say hardenability is the observed one, right? So this give higher hardenability, this give low or something. So I'm not sure which is which, what is what. So make sure the flow is, meaning in the report, it's clear what is the known, and from that known, what you want to observe, that originally unknown, but from the result now it is clear that this is this. So make sure that just the storyline is clear throughout. I assume because you have different source again, I guess, then you have totally different study, perhaps. But you have to specify that if that is the case, and if you cannot merge it, you have to discuss separately. The direction is different. This is testing from this input and this output, etc. Please specify so that I can follow.
this Jominy test showed that the behavior of different metal when it quench and the ability of the metal to harden at different quench rate. So from the distance, from end quench decreases, the hardness of the steel will be increased. Thus, to conclude from this test, the difference between steel, which is almost similar to iron and also carbon metal, can be detected since a small elements of alloying can affect the composition of the metal. Alright, so this is the source that we have referred to for.
Okay, so when you say the last statement in the conclusion, which one that provide this conclusion? So those kind of things in the report, please make it very very clear, right? What, from where exactly this certain conclusion comes about. Because we see genuine tests illustrate the behavior of different metals when it quench, and the metals to harden at a different quench rate. What does that mean? The ability of the metal to harden a different quench rate. Did you vary the quench rate as the distance from quench and increases, the hardness decreases? Okay. Of course, that's obviously expected, right? But what is the difference between the different material, or the meaning and understanding that we derive from that? But anyway, so in terms of the analysis, right? Just now, is it the analysis? This is the analysis, results analysis, right? There are some analysis that you have cited, even though it's again, that table is, I think, from the previous group also show that table. Is it yeah, is it calculated, or is it like an input, right? So alright, so Okay, so we'll go to the next group. Alright, group number 5, let's go. It's already midnight, so yeah. Alright, 2 minutes, nice. Okay, so this is with background music, and okay, the good thing is it's waking me up because it's already midnight. I'm already tired, so this is like, oh, I have to wake up because of the music. But most probably it will be muted by YouTube because I'm assuming the music will be having some copyright or some what do you call that? Basically, it's copyright something that where I have just muted to avoid being strike. Anyway. Okay, so for the objective, I'm assuming this is based on what I've verbally mentioned in the other video. Just to how to say, uh, um, to be more precise with the Jominy test purpose, please just watch at the end of this video where we discuss a bit on that so that you can re-evaluate all the objective and as well the conclusion for all the groups actually, because the way I say it is more of layman to just give a glimpse, because I assume everyone will Google Jominy as well as hardenability and get the full picture, and not just copy what I said, right? Okay, so you actually found this, right? So you actually found what is Jominy test for, to measure the hardenability. But when you say the objective, you say something, you don't use that, right? So that is interesting because this is basically the objective of Jominy test actually, um, to measure hardenability, and perhaps if you use different metal, you want to compare the hardenability between two metals, etc., right? Okay, the first one, because this is highlighted the procedure, good, but when I ask about the why the procedure is done, the first one I'm not sure, but here it is linked to that we need to have different cooling rate. Okay, it's okay in a certain way, yes, because on yeah, it creates that different cooling rate, but I think just add into the understanding of hardenability, right? Why do we want? Because it's not, because if you see different cooling rate, we can just put the whole specimen, put it on the ambient to cool slowly, and then another one quench in water. Obviously that two have different cooling rate, but here is not just about cooling rate, it's about the depths, etc., etc., so extend it a bit so that it makes sense with the respect to the hardenability and Jominy. Wait, so only one source? Why? What happened to the rest? Okay, if you do not, meaning what is this number 43409840? No, maybe you assume everyone understand it, and you understand as well. Okay, but from this perspective of evaluating you, make sure you actually know what's going on. What is that number? What is that number? And yeah, because in the procedure, you never said you test different metals, different materials, right? In the objective also, you didn't say anything about different material. So suddenly you have something like this, people cannot connect what suddenly, why there's many curve. Wow. You cannot even, you do not have even enough time to read, and it suddenly, okay, so that's the thing. Okay, that is that outcome you have to okay, when you say lower distance, okay, ah, this is terrible. Okay, so lower distance from quench and the higher hardness. Okay, that's obvious if you look at the dropping the curve. But lower the distance from the quench and the higher the cooling rate. Is this outcome of analysis? Is this logically, you just can say that even though you don't do analysis, you can already say this? Obviously, when we quench here, this is higher cooling rate and this is lower cooling rate. Because that is not outcome of analysis, that you can just observe and logically it's like that. If you say based on the graph, etc., then that makes sense, outcome of analysis. So number one kind of makes sense, even though in terms of the analysis there should be analysis for Jominy test. It should not end there, but the second one is not really outcome of analysis, right? Okay, so we can conclude that different cooling rate affect the properties. One, the cooling rate itself is never shown in your analysis. Where do you get to know what which is having higher or lower cooling rate? Is there any value related, etc.? There's no such thing there. So I don't, it's not clear how this conclusion is suddenly being achieved, or you come to the conclusion. Yeah, but anyway, for the report, just look at go back to the concept of hardenability as well as the whole objective of the Jominy test to come with the conclusion. And if you use the data that have different material, that should be part of the objective, that should be part of the procedure, hence the data will have that, and then you can conclude something about that, right? Alright, so yeah, we'll move on to the next group. So we are going for group number 6. It is this video. How many minutes?
Assalamualaikum
Just below 4 minutes. Alright, and then you have the information. Alright.
warahmatullahi ta'ala wabarakatuh. So I will explain the Jominy End Quench Test experiment part. So this is our group members and their metric numbers. And so the objective of experiment is we will be able to measure the hardness of a cylindrical specimen using the Rockwell hardness test, and then we'll be able to analyze the effect of the different quenching rate on the hardness of the specimen.
Okay, number one, the objective number one is not really an objective. It is a procedure. We actually measure hardness using that's not an objective, because if that's the objective, you do not. Why is that even an objective? Why a cylindrical specimen become an objective, right? That's a procedure that you do to contribute towards the objective. The second one, yeah, again, that's, I think you just take what I verbally said in the other video. In this video at the very end, please watch that just to update your objective, so that it relates directly to why Jominy test is designed in such a way, and relating to hardenability, right? So relate the objective there to that.
Then we do the Jominy End Quenching Test on our cylindrical specimen after we remove it from the oven. Okay, what the meaning of Jominy End Quenching Test is, we put our cylindrical specimen on the ring, on the quench ring, and then we blow the water to the bottom of our cylindrical specimen, so the heat, it can produce the different heat from at our cylindrical specimen. Then from that we do the Rockwell hardness test on our specimen at different point. Okay, which means we divide our specimen into 4 points to take the hardness using the Rockwell hardness test. Okay, so from that we can measure it and analyze it on the data of our data. The diagram on the left shows us how the quenching rate works, and the diagram on the right is the Rockwell hardness test machine that used to measure the hardness of our specimen.
Okay, so you mentioned something about the procedure, but what was requested is why the procedure is needed, or why a certain procedure is done in a certain way. I don't think you mentioned anything about that.
Assalamualaikum warahmatullahi wabarakatuh. From the data that we have gained from the internet, it was found that the further the distance from the bottom part to the upper part of the specimen, the lower the hardness of the specimen becomes. In this experiment, the specimen that was used is steel. The bottom part of the steel has a lower temperature than the upper part. Why? This is because the quenching test starts at the bottom part of the steel and proceeds until to the upper part. The test on the hardness was conducted at 4 different points as stated in the table. This is to make our calculation more easier and more precise. In conclusion, based on the results and findings of the experiment, we have achieved our objective, which is to measure the hardness of a cylindrical specimen, in this case, steel, by using the Rockwell hardness test. When we do the quenching test, it was found that the hardness were different at each of the 4 points due to the distance from the bottom part to the upper part of the specimen. That's all from me. Thank you. Assalamualaikum warahmatullahi wabarakatuh.
Assalamualaikum warahmatullahi taala wabarakatuh.
Okay, in terms of what you go towards in the conclusion, because you stated in the objective that it's just to see different hardness at different point, or at a different cooling rate, right, or something like that. Okay, because you stated the objective like that, at least you are being consistent. But for the report, you have to update truly why we do Jominy test and the purpose in regard to hardenability, so that the conclusion will have to change as well. Look at the final part of this video where we discuss a bit on that, what to search and what to understand. Alright, so that's group number 6. Let's go to the group number 7. Alright.
Today we are going to present from group 7.
Assalamualaikum. For objective, the first one is to study the difference between hardness and hardenability of the specimen. The second is to perform the Jominy test as a method to indicate the hardenability.
Okay. You also mentioned that to study difference between hardness and hardenability. So I will look forward to seeing what you say about this in the analysis and the conclusion, because you put that in your objective, right? So, and why, how do you study the difference, right? So that would be expected if you specify it as an objective. Second, to perform Jominy test as a method to indicate hardenability. So you have to show in your analysis and the conclusion, how does it indicate hardenability?
The procedure. The first step is to heat plain carbon steel and alloy steel, which is D2 steel, to its austenite temperature. The second step is to end quench each bar with tap water for 15 minutes. We need to make sure that the water is constant velocity. The third step is grind flat along the side of each specimen. And lastly, we measure the hardness every 3 mm form on the quench sites by using viscous hardness testing machines. So by measure the hardness of the specimens, we know the effect by using the Jominy test method on the specimen.
Assalamualaikum.
Okay, so in terms of the task given, because what was specified is why certain procedure is needed, so the why reason is not being mentioned.
So next we go to the citation of resources. In this experiment, we use data from student from German Jordanian University, which we can.
So there's only one source. What happened to the other?
See the front page of the report at the right here. So here also we put the link that we got his report. So next I go to the result, which is first on plain carbon steel. The result we test is the distance from the metal and the quench end and the hardness that we get. As we can see in the table, then we plot it in the graph. We can get as the longer distance from quench end, the lower the Vickers hardness. Next, we proceed with the result on D2 steel. Here we can see that the Vickers hardness test, which we run onto the specimen and we gain these values. Then we put all these values into the graph and we plot them like this, the red color one. And from the graph, we make a straight line with the average of the plot, so that the point up and down the line is the same. And what we can see from the line is that the hardness declines with the distance increasing. So for the conclusion,
Okay. Okay, you try to do some analysis based on the available data, right? But because I think what you refer to is like a student level, it seems like a student level report. So normally you can take that as a highest quality data. My suggestion is not you can still use that, but you have to verify with the concept or the theory what normally is expected to be the case, and because in one of the results suddenly at the end it just jump up back, so it begs question. So you can discuss on that in term of how close that is to the real what should be, or something like that, right? And what happened to the other sources? You have only one. Sorry. So it should be others, right? So how does others compare to this, etc.? So do analyze what you can.
which we can conclude that different materials will produce different hardness. When the distance from the quench end is increasing, then the hardness will be decreased. That is all. Thank you.
Okay. All right. Yeah, by the way, just go to the end of the video to just check out some discussion about I think I have said this, right? Okay. You said the objective is to differentiate between hardness and hardenability. You specify in the objective, but where did you differentiate between hardness and hardenability? Right, so that's an example of a question that comes your way when you specify something is your objective, and then there's no follow up on that objective, right? So everything have to correlate to each other. When you say this is objective, your procedure should match directly. This is exactly why, because this is our objective, and then that's why we observe that, because we want to go back to the objective, and hence the conclusion tally with the objective, right? It cannot be totally separate. Yeah, and of course I understand that for maybe when you start off you have some objective, and then when you find the data it is something, because they do it different, so you have to just see what match, and yeah, filter either way. If I Yeah, okay, so we go to group number 8. Of course, please ask in the Google Classroom, because I make that Google Classroom available for any discussion, any question. Yeah, if you do not use that opportunity, up to you, not everyone needs to consult, but the marking that I'm doing is with the assumption that you have all the opportunity to consult, right? So if the quality of your report, you know, even though you have the opportunity to consult, it will be graded as such. Okay, so group number 8, we'll look at the YouTube link. All right, 2 minutes. All right, nice.
The objective of the Jominy test experiment is to study the effects of different quenching rate on hardness of the material.
Okay, so just go. Okay, I think you mentioned that objective specifically because the way I described the test in the previous video, but for your report, please check the actual full objective of Jominy test, as well as something related to hardenability. Make sure you understand those concepts, and just look at the end of this video as well, just because we will just Google that and see some of the things that you should embedded in the objective, in the procedure, as well in the analysis and conclusion in your report.
Now let's see the procedure of the Jominy test. First of all, we put the specimen into the furnace around 900 degrees Celsius to heat the specimen. And then it is carefully and quickly moved to the quenching machine and positioned above the water jet. Water jet is started and sprayed onto the bottom of the specimen until the specimen is cool. We do this because we want to differentiate the quench rate based on the distance of a certain point from the quench end point. And then we use the Rockwell hardness machine to test the hardness of the specimen at certain point, at certain distance from the bottom of the specimen.
For these experiments, we refer to a report written by Andrew Rebel on hardenability of steel, the Jominy test. You can see the data in this table. From the data, we can see that the hardness of specimen at the distance at 1/8 inches is the highest, which is 56. Meanwhile, the lowest hardness is 34, which is at the distance at 2 inches. If you look truthfully at the table, the higher the distance from end of the quench point, the lower the hardness of the specimen. We know that at the nearest distance, the quenching rate is the highest. This shows that at the highest quenching rate, the hardness is the highest. At the lowest quenching rate, the hardness is the lowest. So, the higher the distance, the lower the quenching rate, the lower the hardness of the specimen.
Okay, for the conclusion of our experiment about this Jominy End Quench Test, we can know the effect of different quenching rate on the hardness value of a material. We can conclude that the higher the quenching rate, which is the nearer the specimen to the quenching point, the higher the hardness of a material.
Okay, so your okay, basically you have to revise and refine objective, analysis and conclusion to link directly to the Jominy test and hardenability concept, right? Because right now it's just purely something that you can achieve without doing Jominy, right? Because when you say higher cooling rate give higher hardness, you can just put two specimen, one after heating, one is in air, one is deep in water, and then you can just conclude as such, just like you conclude, right? That do not need Jominy test. You can use the first experiment, you can already conclude that. So Jominy test have its own purpose, so cover that one, and for some things that you should consider, just look at the end of the video. Alright, so with that we go to group number 9 first. So this is group number 9, last for today. Wow, it takes a long time. Wait, this is more than 4 minutes, that's 60 seconds more. Wow.
We are going to
wait the group, okay.
We are going to discuss the experiment of Jominy Quench Test. Here we have two objectives, which is the first one is to identify the hardness of two different metal specimens at different cooling rate using Jominy Quench Test. The second one is exactly the same, but we manipulate the holding time of the austentination temperature during the heat treatment. We cited from these two sources. The first one is from ITAC and the second one is from Cambridge. There are 5
Okay, in terms of the objective, to identify the hardness of steel, and to identify, what does it mean to identify? To identify hardness. What do you mean by to identify hardness of a particular material, right? Of two different steel. Because normally we would like to identify you just identify it just have one value, right? But in the Jominy case, we will have some curve or some plot. I think in your background there you have the plot as well. So I'm not sure whether it's an issue of lack of vocabulary when you say to identify. So something to rethink there. But in terms of the Jominy, there's a purpose for it, and it links to the hardenability. Just take a look at the end of this video. We'll go a bit on that so that you can refine your objective, enhance your analysis and conclusion in your report.
Essential procedures that we need to ensure we obtain the objectives that we need. First is to identify and prepare the specimen. First, we need to know the dimension of the specimen. As you can see here, this is the quench test. The real quench test is vertical. Without knowing the length of the height of the specimen, we cannot know or divide which part are at different stage. Secondly, is we need to know the steel type, because each steel type has different ostentination temperature during heat treatment. Secondly is the heat treatment. During the heat treatment, we need to know the ostentination temperature and also the holding time, as we need for the first objective. And thirdly is the main thing that we need here is the Jominy test. Jominy test is a quenching which is happen only at one end of the metal steel. The fourth is the hardenability test, HRC, which is Rockwell's test. And secondly, they use Vickers test. The Rockwell's, it is more convenient and it is more widely used because it does not need preparation of the surface of the metal. But for the Vickers, it needs paper sanding of the surface of the metal. Even though it is more inconvenient, it is more accurate. And lastly is the metallurgical test. It is important to know the microstructure of the specimen at different parts of the quenching, and we want to achieve a high percentage of metal sack, because high metal sacks mean a higher metal. The first.
Okay. Generally, I commend you for trying to address, because the question is why certain procedures, so you try to link why you do this, why you do that. Okay, in terms of the attempt, that is okay. But in terms of several things that you have to rethink. Number 4, that you say hardenability test, and then you specify the two. Actually, that 2 is hardness test. So do some reading to make sure you understand what is the difference between hardness and hardenability. Is these two different things? When we say we just use Rockwell or Vickers, it is measuring the hardness. That's different with hardenability. Yeah, you have to read a bit of it, and we use the hardness test at the different location to try to understand the hardenability, right? So it's not the same thing.
Because hardness and the distance, the EN28 and EN4, it produces two different graphs. As you can see, EN28, it produces harder steel than EN4. Secondly, it's the same test but for EMS 45. I did compare these two because it is the different type of metal, and it also have, and from this graph, it does not specify the ostentination temperature and also the holding time. But here it is specified, which is at 900 degrees and 40 minutes. That is for the second objective. Here is Rockwell's test, and the distance for 3 different holding time. As you can see here, the top part is 40 minutes, middle 30 minutes, and lastly we analyze and there are 4 stages. The quench end test. From this we can conclude that the holding time of 40 minutes produces harder overall hardness of steel according to HRC. And lastly, we can conclude that the highest cooling rate produces harder steel, as you can see from this test. We need to find a better site that give 2 examples that does not differ much of its information. As we can see from this, the first citation that we did, it does not specify any oxygenation temperature. It does not specify any holding temperature, which and also different steel that they use. So we cannot compare concrete differentiation between these two.
Okay, thank you for your presentation. Okay, so I think in terms of trying to analyze and trying to conclude based on your analysis, you did a decent job, right? So good job on that. However, I think you really have to, meaning that the missing thing is because when you write hardness and hardenability, you do hardenability, but please revise on that. Hardenability, what is it? Hardness is what is it? And is it related, or how do you analyze hardenability based on reading of hardness at different point? So if you can complete that, I think the analysis and conclusion will become better, as well as because you have to revise the objective, right? Because it's not just to identify the hardness, but from to meaning that is a method to find a way to understand the hardenability, right? Right, so that is, I think, group number 9. So we have completed 9 group. So this is the final part of the video, where in many of the group I said please refer to the final part so that we will see certain things. So I will Google here because this relates to the objective, and from there it relates to certain element of the procedure, why we do certain things to serve the objective, and then the analysis you do, and then the conclusion, right? So when we look Jominy, okay, you can see not Jominy, right? Okay, Jominy End Quench Test. So there are many sources. So if I just go to one, for example, it will already have certain written things that you can straight away. Okay, classic steel hardenability testing. So normally Jominy End Quench Test is directly related to hardenability. Not normally, because that's how it is designed to answer this part. What is hardenability, right? So hardenability, right? What is hardenability? So if you can see here, in this is hardenability Wikipedia, right? Hardenability of a metal alloy is the depth to which a material is hardened after putting it through a heat treatment process. It should not be confused with hardness, which is a measure of sample resistance to indentation or scratching. So that's why the Rockwell hardness is just trying to indent, because it is measuring hardness. That is different than hardenability, because hardenability, when it says here, is related to the depth. For example, we have a material, because quenching, normally when you do have small specimen, right, you just throw in water, it will quench throughout, right? But if you have a bulk, the quench, because the water is in contact with the surface, so it will quench the surface. But the whole bulk here, if this is bulk, right, whether it will cool down or it will quench, or it will because quenching is the effect is it harden the material, right? Like when we do in the other test experiment, when you do quenching and you do other process, you can see the difference in terms of the hardness, for example. But if you have bulk like this, because the surface will be experiencing that kind of quenching, but going through the middle, when you have the depth or the thickness or whatever you want to call it, is the effect the same or not, right? So that's what you want to see. And one way of doing it is basically Jominy, because the specimen is designed as if the bottom part is how to say, that's to simulate the surface, right, which in contact with the water, and then the rest of the distance is to indicate or how to say, is the depth, right? How much or how far it will be affected by the quenching, right? And how it is obviously you can expect quenching here, hardness, and then this one is not really quenching. For example, if this here, it is cooled slowly, right, it's not really quenching in that case, meaning that this is a real this is feeling quenched, this is, you know, So those kind of things. So make sure you try to read some of this to get the idea, and hence when they discuss about the curve, etc. Um, there's a lot of diagram there, right? Okay, so that's where yeah, there's sustainability, etc. So there's a lot of available information online. It's just that at least you understand. Oh, okay, it is to for us to understand hardenability, and then you understand hardenability what it is, and then understand how it relates to hardness at each point, how whatever we observe here contribute towards understanding what is happening in terms of hardenability, etc., and that relates to the objective. And hence some of the group actually find multiple sources. You can do different things because some actually test with different material and see how different material react differently. For example, some use, I think, heating time, or what that group is talking about. So all different parameters. So if that is the uh, data that you will use to analyze, make sure you match the objective, right? So if you have multiple material, the objective have to say something about. We will see what is the difference in terms of hardenability, for example, for different material, namely steel and alloy or whatever. So then in the procedure, that's why we use two specimen, this and this, right? That's one for that one objective. Another objective in terms of hardenability, then that's why we have specimen like Jominy, where the quenching happens here and blah 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 blah. So those kind of explanation is serving for why the procedure is like that, right? So for each objective you have some explanation to do, right? Oh, okay, so that's why you heat it differently, or some use tempering, whatever. Why, right? So normally there's certain objective there that uh, make that leads to the procedure to be in such a way, and then the analysis try to goes back to the hardenability. So whatever graph you see, you try to relate how to understand this in terms of the objective, and the conclusion tied it back. So we can conclude that between these two, for example, objective number one, hardenability, then you say martensite or blah blah blah, and then between these two material, the conclusion is blah blah blah, right? So it has to have a logical chronology. Okay, I'm so sleepy that my words are uh, hopefully my words that come out do not confuse you more, but that's how basically you just seek the information, you feed it back, and hopefully you can do a great report, inshallah. Wallahu alam. I think I'll just end it here. Wallahu alam. Assalamualaikum warahmatullahi wabarakatuh.